Welcome to The Long Run. This is a podcast for biotech adventurers. I'm your host, Luke Timmerman. Today's guest is Elias Zerhouni. He's the president of global R&D at Sanofi, one of the world's biggest makers of drugs and vaccines. Zerhouni, for those unfamiliar, has had quite a career. He started out as an academic researcher in radiology at Johns Hopkins. He then became an entrepreneur and an academic administrator. He served as the director of the National Institutes of Health under President George W. Bush. He took his current job at Sanofi in 2011. Zerhouni also happens to be an immigrant, a native of Algeria, a Muslim-majority country in North Africa. I wanted to ask him about that life experience and how he got to where he is today. In this episode of The Long Run, we spoke mostly about how immigrants are crucial to the scientific enterprise. At the risk of stating the obvious, immigration is one of the reasons the U.S. remains the number one place in the world for biotech and pharma innovation. We also talked about the threats to government budgets for scientific research, and what would happen if budgets get slashed at a time of so much possibility in biology. Now, before we get going, a couple quick plugs. Some of you may have heard that I'm training to climb Mount Everest in 2018 as part of the Climb to Fight Cancer. This is a charity fundraising program at the Fred Hutchinson Cancer Research Center in Seattle. I'm thrilled to be a part of this inspiring program to support cancer research and science itself. I'm training hard. Thanks very much to EBD Group for its support as a base camp sponsor of the climb. EBD Group, as many listeners know, co-produces the Biotech Showcase Conference each January in San Francisco. I'd encourage you to go register for the Biotech Showcase today. I'll be there on a media panel as usual. By registering for the Biotech Showcase today, you will get to attend a great networking event. And if you would be so kind, when registering to attend, please leave the organizers just a brief one-line comment to say you appreciate their generous support of the Long Run podcast and the Climb to Fight Cancer. Sponsorship is necessary for me to continue doing this show. I'm an entrepreneur, and I've been shouldering all the production costs out of my own pocket the past few months to get it going. Now, of course, if you like this podcast, I'd encourage you to go to TimmermanReport.com and subscribe. If this show is the appetizer, then TimmermanReport.com is the full meal deal. It goes for the bargain rate of $149 per reader per year. The next episode of the Long Run podcast will feature Steve Holtzman. He's a veteran biotech executive and really someone who has seen it all. He's currently the CEO of Boston-based Decibel Therapeutics, a startup working to treat hearing loss. Holtzman has also been quite outspoken over the past year. He has helped mobilize other biotech CEOs to speak out on political issues they have historically avoided. Watch for that episode in your iTunes or Stitcher feed. Now, join me and Elias Zerhouni for The Long Run. I'm here today in New York City with Elias Zerhouni. He's the Executive Vice President of R&D at Sanofi. Welcome. Thanks for joining me today, Elias.
Thank you, Luke.
So I'd like to ask a little bit about you first, to introduce you to our listeners, and then I'd like to talk about a couple of major issues in our country and facing our industry, that being immigration and funding of basic sciences at the NIH, which you're very familiar with, and we'll get there. But first of all, I'd like to ask you a little bit about your background. You were born and raised in Algeria.
That's right.
And this is a country where the vast majority of the population are followers of Islam. You got your medical degree there.
That's right.
And then came to the United States for your medical residency at Johns Hopkins.
Right, radiology, actually.
So what brought you to America?
Well, it's simple. I had a very unusual set of skills that my father was a teacher of mathematics. And so for him, mathematics, physics, engineering that was where the action was. And I grew up in a family of 7 brothers. And I was number 5. And so I was very, very good at physics and math, but then I went to volunteer when I was a student in the mountains, and I saw the misery of people who were poor and suffering from tuberculosis, and I wanted to make a difference there, so I decided to go to medical school. So when I went to medical school, I realized that medical school in those days was very much rote learning, recipe learning. It didn't have that profound beauty and logic of math and physics. And then one of my teachers showed me a CAT scan one day, and he said, "Oh, this thing is a new method to look inside the brain," and there was a very fuzzy picture. And I said, "How is this acquired? How is it done?" And he said, "Well, there's a computer, and then there's an X-ray tube that turns around the patient. The data is sent to the computer. The image is reconstructed." And I clicked because I said, "That's perfect. That's exactly what I am good at, understanding mathematics, but I also like biology. I like medicine." And so I decided to pursue that.
Now, this would have been the 1970s.
Yeah, 75.
So you're in medical school.
I'm in med school.
University of Algiers?
Yeah, and I'm finishing med school at that time, and you had to decide what you wanted to do. So that moment told me I want to do computerized imaging, and I want to be in the imaging sciences and at all levels, and especially quantitative imaging, where I thought there was a lot of potential. And so when I wanted to do that, my medical school said, "We don't have a program. You have to go abroad and go train, come back." And I said, "Where do you train?" I said, "Well, the U.S. or Sweden at the time, or the U.K." And that's how I learned English, and I took my exams, and my equivalency exams at the time was called ECFMG.
So growing up, you spoke Arabic?
I spoke French, I spoke Arabic, and I learned German at school.
But not English?
Not English, yeah. Which is probably a good thing, because I didn't learn it badly. I learned it here in the U.S. And, learning it in immersion with the people who speak it allowed me to probably speak it better than I would have if I had learned it at school.
Okay, so you decide to come to the United States. Did you ever consider one of those other countries?
Yeah, I consider Sweden, and because Sweden was very, very good in imaging sciences at the time, the UK. The opportunity was really in the US because the dean of my medical school knew the dean of Johns Hopkins, and I had a scholarship for 3 months. I had won that as a medical student. And so he talked to him, and I had asked that my dean. I said, where are the best schools? He'd say Harvard or Hopkins. I said, well, if you get me a shot there, I'll go. That was it. And funnily, he called the dean, and who knew him because my dean was actually a former NIH scientist. He had done research there and was a very well-known neurophysiologist. And so he said, look, I have this kid. I don't know what he wants to do. I can't offer him any program here. Can you take him for 3 months, 6 months, so he can see what it is and decide what he wants to do? So that's how I came to Hopkins on a scholarship that I decided to spend the time at Hopkins doing research on computer tomography. Computerized tomography.
So you're already focused on radiology.
Yeah.
Hopkins was a great place then, as always.
Yeah.
It's 1975.
Yeah, that's correct.
And you come here by yourself?
No, I came with my wife. Actually, we had just gotten married, and 2 weeks later we left. Our honeymoon was Hopkins.
Okay.
Working in the lab there.
How did you come? Was this on a student visa or some other?
Yeah, no, it's these exchange things that I can't remember what category it was, but it was an exchange visa at the time.
So how did things go in the early days there at Hopkins?
It was interesting. The first day I arrived there, my English wasn't so good. So the vice chair, Stan Siegelman, was the name of the vice chair. And he talked to me and he said, you might want to go take some English before you come here. And I said, no, I can't do that. He said, why not? He said, I only have 3 months of a scholarship, so I'll be gone by the time I learn English. I want to do what I need to do. And he said, really, you want to do that? I said, don't worry about me. I'll do it. Because I knew how to read it and write it, but I didn't speak it very well. Then I went to see the chairman, who was actually German by birth, and immigrated from the East Germany in the 50s. And he noticed the same thing. He said, well, what do you want to do? And I was in my broken English. And he said, well, I don't quite understand what you're saying. I said, well, let me speak in German. So I spoke German to him. And he said, well, your German is very good. And I said, yeah, but that doesn't help me here. He said, well, if you learn German, you can learn English. And from there, I went with the medical students first to go through, getting used to. And then I started working, in the lab. And within like 3-4 months, I made some contributions. And then I worked in the emergency room to make some money. So I learned the hard way at night in the emergency room at Hopkins. And then by the end of that, they offered me a residency position. One of the residents left the program, so they had a spot. And Stan Siegelman, who had not seen me for a few months, talked to me and said, well, your English is much better. And in those days, imaging was not that popular. It's not what it is today. It was really still considered backwater, but I thought it was the up and growing technology for biology.
When did you decide you wanted to become a citizen?
Late, actually. Initially, I didn't want to. I wanted to go back. And then what happened was really pretty simple. The situation degraded itself there. I tried to go back, couldn't find a welcoming environment, and Hopkins said, look, we have a position for you. Go back, see if it works out. If not, come back. And so I came back.
How did it degrade?
Well, basically, I think the political system became a little more corrupt. It was more authoritarian. And then the situation that you have, if you stay too long abroad, you're perceived as a foreign body. That, oh my God, he's coming, he knows all these things about, the advanced technologies, he's American trained, he might take our job. So then you get this sort of pressure, and that's one of the things that I know you want to discuss about immigration.
Yeah.
Well, a lot of immigration is in one-way street. There's not a lot of ways to come back unless the country that sent you is willing to bend over backwards to get the returnees.
Well, you had a position at Hopkins. Mm-hmm. You obviously, it didn't take you very long to find your niche in radiology. Yeah. When did you decide that, this is where you really want to be long-term and build your career?
You mean in terms of the U.S.?
The United States.
I really, 81, 82, 6, 7 years into it, I really, Hopkins has been such a great institution for me. And it was very nurturing. The opportunities were great. I needed to do, work to get a visa, obviously. So I didn't become a citizen in 81, became a citizen later. But that was the decision. It was about that time. I had 2 children. And there are things that happen. My wife was in training. She's a physician, too. Things that happen that you don't really control. And they dictate almost what you want to do. But frankly, things were going so well that it would have been not so smart not to take it on.
So we can fast forward now. You've carved out this academic career at Johns Hopkins. You're specializing in CT and MRI imaging. This is radiology kind of at the beginning of a great boom era. Yeah. You're making inventions, you're publishing papers, you're starting companies, you're working your way up even into administrative roles later in your time at Hopkins. You eventually get to become the director of the National Institutes of Health. Yeah. I think a lot of people would look at this background and say, what a classic immigrant success story. Yeah, this is fantastic, right? You've probably heard this 100 times.
Yeah, actually, I heard that in my, when you get to be NIH director, you get nominated by the president, but you get confirmed by the Senate. And it was interesting in those days because the president was a Republican and the Senate was controlled by the Democrats. So you had to have double hurdle. You had to pass the first thing and be qualified to run the NIH. And at that time, the administration had decided that they wanted an external person to transform the NIH, change the NIH. It was too much into its ways. And frankly, I wasn't beholden to any particular group or any particular strategy. And what I had done at Hopkins as Dean for Research and the Executive Vice Dean had been noted. So I had been elected to the Institute of Medicine, and so I made the list, if you will. But the thing is, the confirmation, and I remember it was Senator Warner, I think, and his first statement was, well, I'm so glad to present Exhibit A for the American dream. So you're right. But I always feel that that's a sort of caricature. Frankly, it's not the immigrant who is special. It's what I said when I was confirmed. I said, it says more about the U.S. than it says about me. The U.S. is unique in that regard. I mean, only in America could this happen. If I had been in France or UK or so, I don't believe it would have happened in any other country, including my own mother country.
So, when the things have happened in the last year in this country, as you know well, politically, there's a wave of anti-immigrant sentiment that brought a new president into office. We had a travel ban enacted in January against people from majority Muslim countries. There's been the recent rescinding of the DACA executive order that protected children of people who came here illegally. This has upset a lot of people, I mean, in the country, but also in the pharmaceutical industry, where I believe about half of the biomedical researchers in this country were born in another country. First of all, what has been your reaction to this anti-immigrant wave of sentiment?
Well, it's a global wave, actually. I work between Europe and here in my job, and I see it in Europe as well as I do here. In really maybe 20-30% of the population. It's not a majority thing, but it is there. And I think the U.S. is no exception. It has multiple sources. Obviously, as you understand, I mean, people are afraid of the foreigner, and there's this thing about, so there's a little bit of xenophobia and afraid about jobs. So there's a bit of economics in there, although, with an unemployment rate of 4.7%, you say, well, what's going on? But people are saying, well, it's depressing wages. And so I can see all the reasons, but the response is not the right one, because fundamentally, when you look at immigration and sciences, one half of all the Nobel Prizes actually were won by people of immigrant backgrounds.
You mean Americans?
American Nobel Prizes, yeah. Uh-huh. And so there was a study recently, I just read it, that if you apply the rules that we want to apply today of the 31 Nobel Prizes that were won since 2000, only 3 would have been accepted in this country, 29 or 28 would have been turned away. I would have been turned away. I don't think I could make it today, and I would not have contributed both in my science as well as my, administrative leadership or my startups and so on. So I think it's short-sighted to really lump everything into one populistic slogan. I think you need to be smarter than that. Frankly, it's a disservice to America and its mantra, its creed. I think America holds together not because of ethnicity or geography or religion. It holds together because of its constitutional principles, and that's what I think is critical. And clearly, in science, more than anything else, in technology, more than anything else, the degree of enrichment of our economic base because of that is enormous. Half of the companies in Silicon Valley have been created by non-U.S. born citizens. And if you look at the big companies, would be Microsoft, Google, Novartis. I mean, you name it. You see this explosion of talent that we've been able to attract and retain. If we don't do that, it's almost like giving away the human capital that the country needs. It's what happened to Germany when Germany expulsed all the non-German and the immigrants and the non-pure. What happened was the greatest gift of human capital a country ever gave for free to the United States. I mean, all of the great scientists that came out of that exodus have made us win the war in part. So I think there's a historical dimension that is missed for the purposes of short-term political gain, which, you can understand. People are afraid. People are insecure. People basically want a scapegoat.
Running a global R&D enterprise like you do understand that the most valuable assets of the company are the people who walk in and out of the door every day.
Yep.
And not just in companies, but in academia as well. And the fact that the United States has had generally open borders for many, many decades, welcoming to people like yourself, is a key part of the reason that this is the place where most biomedical innovation occurs. Mm-hmm. It doesn't occur in the Netherlands or France to nearly the same degree.
That's right.
More homogeneous type places. Are you planning your trip to San Francisco in January, like so many biotech executives and investors? Check out the Biotech Showcase, co-produced by EBD Group. This meeting at the Hilton Union Square, San Francisco, is a beehive of biotech and an annual tradition for me. It is a place to connect with interesting people working on all kinds of provocative ideas. I'd like to thank EBD Group for stepping up as the first sponsor of the Long Run podcast. When you register for the Biotech Showcase, please just type in a brief comment to say you registered after listening to this show. Not only will you get to be part of a great biotech networking opportunity at Biotech Showcase, but you will support this podcast and encourage EBD Group to see the value in its sponsorship over the long term. How does this new political reality affect the operations of a company like a Sanofi on a day-to-day basis? I mean, do you hear stories of scientists who need to travel to one conference or another, and they're afraid that maybe they can't go or can't come work here in the first place?
Not much to date, because a lot of the policies and statements have just not been effective. I mean, the ban did not go through legally, and all of the measures that people are talking about have not yet taken their effect. The big one is going to be the H-1B, the number of visas that are decreased. That's the quality, that's the band of people, the type of people we most want. The ones who are super qualified that often we trained ourselves. We have all these PhD candidates and these postdocs who are in our country today and are contributing today. And I'm afraid we're going to lose them because we're restricting the ability for us to recruit them here. What that means is that they'll go to China and I'll set up a lab in China or in France or in Germany. So it will have a long-term effect, but I don't know that it has had a short-term effect at this point in time.
You think that's a real possibility that we could lose the United States leadership?
Oh, we're already, if you look at the trending in patents, for example, publications, I mean, the gap between the U.S. and the other countries is closing, especially when you look at the European and China. And, there's been a welcome widening of the number of people who are at the top of science in the world, and that's really important to solve our problems. So I think the supremacy that we enjoyed in the 50s and the 60s and the 70s is waning. It's not the same degree of supremacy that we have. However, when you look at true innovation, transformative innovation, the ability to really translate that into an economic reality, you can see that the U.S. is still the innovation country.
So all is not lost, but it can't be taken for granted.
Never. No, if you take human capital for granted, you've lost.
So have you had an opportunity to speak to some members of Congress or members of the administration? Given your background as former head of NIH, you know some people there.
Yeah, I've written an editorial in Science a few years back because this topic comes on and off all the time. It's not a new topic. When you look at immigration, it's been a festering issue which has divided people and frankly needs resolution, but there's no political win in trying to resolve it, as you can see from the experience of those who tried. So I think, from my point of view, I think we need to say what I just said, and I share it with you, and I share it with anybody who wants to hear me, is that a good percentage of the economic future and the economic present of the country is driven by our ability to, what I call, enrich the mix. And I wrote an editorial saying that, in science or in enterprise or anything, the difference is made by a few people. And I call that the enrichment of uranium, right? When you want to make an atomic weapon, uranium-238 is very common. Uranium-235 is rare. But uranium-235 is what makes the difference, right? It's the same thing in human capital. 98% of science is created by 2% of scientists, right? So 2% of scientists worldwide is not a big number. But if we can attract that, then we have a successful future in front of us. You understand?
Yes, but it's also, I've also heard of the weak ties hypothesis. Have you heard of this?
No.
That we get the best ideas from the people who are not in our immediate circle. The
True.
people that we see and talk to every day, we kind of have a good feeling for the way they think about issues and problems.
True.
But it's the bumping into, it's when you're a molecular biologist and you bump into the biochemist at the water fountain and you say, hey, I thought about this from a different angle.
Yeah.
And that's when the connectivity occurs, the sparks fly. And that also is aided, I believe, in part by diversity, by having people who are trained in different places.
Right,
together.
So you're completely right. Actually, I believed in that in the 90s when I set up my lab at Hopkins. I created it that way. It was a multidisciplinary lab because I believe in what I call scientific convergence. So what you see today is that biological sciences are converging with physical sciences, converging with mathematical sciences, with information sciences, in a way that just wasn't there 20 years ago. You could have a great career in a silo field. Not anymore. And this is probably one of the reform I brought at my school, which were noted by the folks who asked me to direct the NIH, because I believe in that. So when I did the roadmap for NIH, one of the tenets of the roadmap was interdisciplinary research and how to encourage it, how to avoid the silos, how to break the barriers between not people but disciplines as well, and create that diversity of ideas from which history will tell you great transformative ideas come from and great research comes from. So you're completely right. It's not just an immigration problem. It's also a diversity of backgrounds and ideas that tend to accelerate the progress of science. Science goes to the country that welcomes it. And scientists throughout history have gone to the countries that welcome science. So when you look at Athens, or you look at Baghdad and its big day of wisdom, and then look at Renaissance, and what you see is the scientists migrate to where the society at the time welcomes it and encourages it, and that's where you see economic growth and economic brilliance at the time. So, if you look at every country, I don't know of any civilization that succeeded without attracting a diversity of talents from different horizons.
Now, this leads me into another point, which about the welcoming of science, as you say. We also have an environment that's anti-science. There's a strong strain in the culture that's very skeptical of things like climate change or the use of vaccines, and really anything that were to come out of peer-reviewed research. Creates a difficult operating environment. Does that concern you?
Well, yes, absolutely. I think there's been a change in the public attitude towards science and technology because of the environmental damage that unbridled industrialization has done. I think that the side effects of certain advances are, put in great magnification. A few complications in vaccines, for example, have led to the sense that vaccines may be dangerous for you. There is the a rise, if you will, of what you would call non-scientific ideas and theories that people do buy into. So that's one thing. And if you look at the trust level of the general public towards science and technology. It was highest in the 50s, and it's not, it's half and half right now. So science and scientists have not done a good job, I think, yet. They need to do more in truly educating. We're not doing that very well. The scientific fields, what we call STEM education, is not served well in our educational system. So quantitative, logical, analytical skills are not there for allowing a citizen to say, well, what's right, what's wrong. The rise of social network and the multiplication of that. So all of that tells you that there is a need for us to truly do better. The second trend is the issue of vested interests. I mean, if you move economic systems away from coal energy or away from, you get obviously a reaction, which is what I think explains a lot of the global warming debate that is ongoing. The sense also that the balance of evidence is never perfect. So you cannot prove 100% of anything. And the balance of evidence is really what you should look into. But some people, catch on to 2 or 3 outrageous papers that have not been validated, and they make a policy out of that. Or they ignore 97, 98, 99% of the other evidence. And then the third source is what you mentioned initially, which is really the religious versus science debate that has gone on, with science being seen by the religious people as anti-religious and scientific people looking at religion as anti-science. That's a false debate. It really is a debate that unfortunately led to the Middle Ages. And when that was resolved in a way by Francis Bacon and the Renaissance occurred. So you have to be very careful, because absolute declarations that science is the enemy can be very destructive of society. So,
well, we see its downstream manifestation in things like a proposed 20% cut to the NIH budget. Now, to some people looking at that at first glance, they might think, well, that could just be there's waste, there's fat to trim. Maybe that's just good stewardship of the taxpayer dollars. I happen not to believe that. But what do you see when you see something like that proposal come through?
Well, it's driven by ignorance, really. They don't appreciate what the ecosystem of research is, has been, needs to be, and will be. It was created by Vannevar Bush in the 40s. He was an advisor to President Roosevelt, and he wrote a paper called Science, the Endless Frontier. It's probably the most important paper of the 20th century because it dictated American policy relative to that. We wouldn't be the power we are without that strategy of saying, look, the success will come from the tripartite collaboration between industry, government, and academia. And he made it happen. The atomic bomb happened because of that. The radar happened because of that. It didn't occur inside either one of those three. So if you really want to succeed, you need to understand that the role of each is different. Academia is discovery, new ideas. Government is really infrastructure. So when we say indirect costs are very relevant to the vitality of your research. So 20% cut was more dictated not by an anti-science feeling, but as a small government, no waste in the government, and the sense that maybe universities were overcompensated, which is not the case. And Congress actually voted that down a couple of days ago. So I think it's a false debate.
But the point, one of the things I think Bush was making in that paper was that we should invest as a government in basic science and trust that it will, we don't know which directions this will always go. That's the definition of basic science. Right. But it will, that this is an investment that only government can make. Industry is in the business of more applied research right. and development, and it's part of a continuum. We need all of it. Yeah. You can't just, out of ignorance, declare, oh, we're doing fruit fly research with government funds. What a big waste of money. Fruit flies have taught us a lot about genetics.
That's right. I mean, without fruit fly, we probably wouldn't know how to appreciate genetics in humans today. I think you're right. I think, to me, the priority of the investment of the government should be threefold. One is basic research, right? But basic research not done by machines. It's human capital formation that I'm talking about. The people who get educated and become capable translators of universal principles into discoveries of the basic type. You can't do basic research without having a policy where you can sustain and support young investigators who want to give their lives to the discovery of new principles that could potentially help, but that's not the purpose. The purpose of basic research is to understand the universe.
But we already have a big problem with the human capital development because of NIH budget stagnation in recent years. It's become much more difficult for young scientists to win that first peer-reviewed grant. They're often in their 40s. Many people leave science before they ever get there.
Yeah, I see that as the number one issue, frankly, in my view. I've been a very strong advocate of young investigator funding. I did that when I was at the NIH. I created programs that allowed us to fund brilliant young scientists earlier than what the system does. I think it's a demographic issue too, with the baby boomers, having crowded the space, if you will. But I think that is an issue for the whole country to deal with, because it's not just NIH or biomedical research. It's the same thing everywhere. So I think we need to preserve basic research as a government-funded activity, because it's through that activity that you create a very capable human workforce, scientific workforce.
And that's why when I see something like a 20% budget cut, knowing that we already have a extraordinarily difficult environment for young people, basically we would be turning away an entire generation of young scientists.
That is the risk. I've said that. I wrote in that regard editorials with Rush Holt, the AAAS president, and others. The impact it would have is catastrophic, because when I was at the NIH, we had Katrina, if you remember. Mm-hmm. Well, Katrina, because it really cost a lot, forced us to cut every agency's budget, and it was only 1% for NIH. But people forget that NIH only gives 5-year grants, so any 1 year they have 20% of their budget available to them. So if you cut year to year, on the same year, you cut 1%, is equivalent of 5%. Yeah, 5% is actually a quarter of the grants, right? Because you have 20% to give, you take away 5, and so the impact was dramatic. The number of young investigators funded that year went from 1,800 to 1,000. So I had to react and create a new policy that said that we need to preserve the next generation of scientists.
Now, why is this? Now, we could.
So 20% would be dramatic. It would basically stop every new grant. Well, new grants are usually associated with new scientists, next gen.
Now, we could sit here and make moral arguments about immigration, and I think common sense, long-term arguments about basic science funding. But in wearing your hat as a pharmaceutical R&D leader, why is this just good business to have reasonably open borders and proper channels for people to come here and, robust basic science funding?
It's good for not just business, it's good for the economy as a whole. You don't make anything happen without bright people who are in that uranium-235 category that I'm talking about. Well, where do you generate those? You generate them through basic research that trains capable people who get excited by discovering new things, eventually become the workforce for academia, for industry. They become the professors, they become the researchers in industry, and they can be from anywhere. So that train of basic research leading to translational ideas, that creates a whole generation after generation of capable scientists, capable translators, capable engineers across all fields, is absolutely essential to a strong economy. It's not just business. Business is only a reflection of the economic prowess and potential of any one country.
But you don't just import those people. You bring them in when they're 24 years old, like a young Elias Zerhouni, and then you nurture them. You develop them. You give them the freedom to pursue wherever their ambitions will lead.
And the thing that's good about our system is that it rewards performance and it rewards excellence. It doesn't reward who you are, where you're from, what age you are. It depends on what you accomplish. As long as we keep that and we give the pump the ability to prime itself with new talent all the time, we'll be the best country in the world for a long time.
One last question. The central problem in pharmaceuticals is this lack of R&D productivity. The time, the expense, the risk that's still involved in developing a new drug. It's awfully high. I know you're doing a lot of things to try to improve that. You're investing in lots of technologies. You got partnerships. I asked one of your partners, George Yankopoulos, about this a couple weeks ago. But what's your philosophy on how the industry can kind of slay this dragon?
I really think it's not just an industry issue. It's really a knowledge issue. What I always tell people is that I thought I knew more about biology when I joined the NIH than when I left the NIH. Because I was a little bit arrogant when I went there, and I've been a successful academic, and I thought a lot of things were known, and I developed imaging techniques for cellular and molecular things, and I was like all excited. And I said, how come these guys can't develop a vaccine? There must be something wrong with them. Well, what you realize is that we just don't know enough. So translating something you don't know is really hard to do, especially that, biology, we've learned a lot about biology, but we haven't learned as much on human disease biology. So we have work to do. And translating from something you don't know becomes a little bit of a statistical game, stochastic in nature to some extent, where you try to make bets, and the success rate is what it is. In addition to that, regulatory costs and the expense of having clinical trials now, which is the biggest expense, is just skyrocketed. Healthcare costs are high, and they're very, very high in the U.S. in particular. People complain about the cost of drugs, but look, the cost of hospitalization is 4 times what it is in Europe, and on and on. So conducting trials has been exponentially more expensive in a field where we don't quite understand what we need to understand in disease biology. When I ask people who know, they say, do you think we know 10% of what we need to know or 50% of what we need to know? Most people would say 10, 15%. So we still have a lot to learn.
Everybody has their part to play in academia and in industry.
That's right. Yeah. Well, millions of people are waiting and hurting, and so we need to hurry up and not create false problems like the ones you mentioned. We need to fund research. We need to really continue to understand the fundamental impact of science and technology on our economic future, and that can only be done by dedicated people that feel encouraged and feel like their career will be better or at least as attractive in a field like this than it would be in real estate or finance.
I don't know if you could answer this, but if you were, in your mid-20s coming up in Algeria in 2017, do you think you'd still come to America or see it in the same way?
I asked that question actually from young people I know, and I have my best friend from school. He has 2 children, and they both went to China. So I was like surprised, and I asked him, why would you go there instead? He said, well, America is really, rejecting us and so on. It may have to do with the fact that they're from a Muslim majority country, and they feel like maybe they'll be ostracized or whatnot. And I try to tell them otherwise. I still believe America is the country of innovation, and you can see it. We still have that momentum. And if we lose that, then we've lost the country and its potential for innovation.
I'd hate to see it, especially at such a moment of great potential.
I know you say that, and everybody says that, but I'm completely optimistic about the future, to be honest with you. I'm not pessimistic at all. We need to fight the things that could derail that. But frankly, when you look at what we have as a society, our universities, our schools, and so on, I still believe that we are the country of innovation. We are the country of experimentation. We are the country of transforming ideas. And if you travel the world, you will see that the influence that this country has in sciences and technology is enormous. I haven't seen yet a transformative technology or a transformative something coming out of some other country that wasn't derived from what had happened here. So I think we shouldn't give up, and we shouldn't be so pessimistic that we get paralyzed. I think we can fight, and we should. And this is what I think makes our country great. But also for humanity. I mean, if other countries stop, because other countries also are not funding research the way they should, except China maybe. And if that happens, then what, right? What? I mean, we go back into the dark ages or what? So I do not believe that the future is as bleak as people think it is. The young people think it's bleak, but you know what? We fund more researchers now than we did in the past because there are more sciences to fund and more disciplines to support, and the interaction is the key. So I think there is a little bit of over-pessimism that I don't think is justified. And we need to fight for optimism, not for pessimism.
Well, I'll take a little dose of optimism today. Thank you very much for joining me today, Elias, and I'll let you get back to work.
Thank you. Enjoy. Take care.
Thanks for listening to The Long Run, a production of Timmerman Report. Pedro Rosado of Headstepper Media was the producer and editor. Music for the show comes from D.A. Wallach. Todd Bennings created the logo. Thanks to EBD Group for sponsoring this episode. Next on The Long Run, listen to my conversation with Steve Holzman. A more than 30-year biotech veteran, Holzman has become quite outspoken over the past year on a number of issues. He has helped mobilize other biotech CEOs to speak out on political issues they have historically avoided. Don't miss this upcoming episode of The Long Run.